Welcome to JCON!
Hi everyone, my name is Richard. I'm one of the organizers of JCON. On behalf of the whole JCON team and our sponsors, I would like to thank you for joining JCON today. We appreciate your attendance and hope you will have fun and learn something new. We've got an exciting agenda for you to explore. A big thank you to everybody who made JCON happen, and a special thanks to our sponsors. Make sure to check out their websites, products, and services for the Java community. For our keynote today, I would like to welcome the founder and CTO of Axonic, Elad Bauze. Hi, Elad.
Hi, Richard. Hi, everyone. Let me quickly share my screen. Right, there we go. That should work. So welcome to this session about DDD, CQRS, and event sourcing, and especially beyond the hype. I understood that some people were already excited about the hype part. DDD, CQRS, and event sourcing beyond the hype and beyond any technical challenges that are thrown at us. Let's see if we can move the slide. Yes, we can. Fantastic. So I want to take you a little bit back to back in history, once upon a time. And for some of you, that might have been yesterday. For some of you, it might have been, well, a decade ago or even longer. But at least for me, a decade ago, the way I built software was more or less with an architectural style like this one. There's a cylinder to the right, and that cylinder would hold our gold, right? That is the current state of everything we know. That is how we know the world to be right now. But because we don't want applications to just poke in that reality unguarded, we put some boxes in front of them. And those little boxes in front of them will hold various types of logic that safeguard the business requirements and etc. everything we have, but also the kind of user interface logic that we have. And because we didn't want to put everything inside of a single box, we put some boxes in front of them. And this is also known as the layered architecture. It's an architectural style that originated somewhere in the 70s, as far as I can find. I had to look in the history books for that. I cannot use my own memory. Fortunately, I guess, but and it is still a dominant architectural style nowadays. If you just look at how most applications are built up, you can still see that box cylinder style architecture in them. Unfortunately, that box cylinder style architecture very often leads to what we call a big ball of mud. And here is such a picture of a big ball of mud, and you'll notice two things. First of all, it's not really made of mud. And secondly, the architect is pretty proud of its creation as well. You can see it here sitting on top of it. But we all realize that a big ball of mud is smelly and it's not fun to work with. And that's why all these software projects, they grow more and more complex over time, and they become harder to maintain. So around 2014, we had microservices to the rescue, right? All problems would disappear like snow before the sun, because now what we could do is lots of little box cylinder scattered across our entire landscape. And recently I read an article suggesting that these services should be structured in such a way that you have entity services, that you have some business related services, and that you have services that focus more on the user experience. And when I read that, I thought, but doesn't that give us little box cylinder squares around our architecture? And then basically we reorganized them again to form sort of the box cylinder architecture, even on a meta level. So we'll now have basically, well, we'll see in a second. So we take the style, the architectural style that leads to a big ball of mud. And what we do is we increase the number of deployment units. You just get a big pile of mud, let's say. What we should be focusing on instead, and I'm very happy to see later this afternoon, there's going to be some talks about those topics as well, is we should be increasing the modularity of our systems, not the number of deployment units. When we increase the modularity, and that's really easy on a PowerPoint slide, you just use fancy colors and put less lines in between certain boxes, and then you have modularity. In software engineering, in practice, when writing code, it's a little bit more involved than that, but there's a few principles that we'll be looking at. Once we have this more modular structure, we can then think about increasing the number of deployment units. So actually going to microservices is not about the microservices themselves, it's about modularity first. And that's the part we very often get wrong. Again, reality is different than a PowerPoint slide. So in that reality, there is a lot of anti-modularity forces. And these anti-modularity forces are the forces that drive our architecture down to the bottom again, that force us to become a big ball of mud. And those can be very simple things like technical debt, like cutting corners to just make a deadline. And those are absolutely fine, but just like any debt, you have to think about repaying it before incurring it. If you cannot pay the debt, don't get it. But it could also be deadlines moving, right? Or a technology that is deprecated, or whatever reason that may find that causes these sorts of technical debt. And the further you get to the right, the stronger these anti-modularity forces become. The harder it is to maintain the level of modularity that you will have in your environment. Now, recently, there's a new surge, let's say, of reactive. And I'm not talking about reactive programming, but I'm talking about reactive architecture here, reactive systems. And you might have seen this diagram. And recently, there was a document has been published called the Reactive Principles. And you can find it at principles.reactive.foundation. And it's definitely a recommended read. I had the pleasure to write a few snippets for it as well. And the idea is that we want maintainable, responsive, and extensible applications or systems as a whole. To be able to achieve that, we have to think about elasticity and resilience. And to achieve those, we have to be message-driven. Now, something very interesting happens when people think message-driven. We think events to the rescue, because events are messages and they're very powerful. Now, the concept of events is very simple. When you have two components that need to interact with each other, of course, one way could be to have that one component just invoke the other, either directly or through an ACP protocol or whatever protocol you'd like to use. That works when there's just two components. However, when that service needs to communicate to more than one component, you'll find that you'll need to modify service A to connect to the other ones. And if one service is down, what do you do, et cetera, et cetera. So if you need to notify a magnitude of components for something, instead of invoking them directly, we can use events. Right? So service A can emit an event, and services C, B, and D, in this case, can just watch that space where these events are published and react accordingly. And this is fantastic because now service A doesn't need to know which components are reading its events. and you are much more flexible. So what do? We, as in the collection of all developers, including myself, we implement a universal event-driven microservices architecture, which again stars our beautiful big ball of mud generators, the box cylinder services. But what we do now, instead of having them poke each other, they will all publish to some shiny technology sitting in the middle. And that's where they all publish their events and consume their events. And now we have one big event-driven system where every component can interact with any other component at any time. The promise that we have been told with this architectural style is, well, we take the box cylinder architectural style, and instead we increase the number of deployment units, we add event-driven messaging, and the promise is that we get rainbows and unicorns, right? It will all be happy and we'll all live in a fantastic world. And I'm pretty sure my daughter would love this. But reality is that if the box cylinder architecture gives us a big ball of mud, and if moving naively to microservices gives us a big pile of mud, distributed mud, adding events to that will basically give us a big pile of, at least it's smiling, but a big ball of mud with events sticking out of them. And that is because the reality, or the picture that is painted for us is always a beautiful image, right? If you look at travel brochures, when I saw this image, I thought, oh, this is a place, this is where I want to be, right? This is fantastic. There's sunshine, unlike where I am right now. And it just looks amazing. However, there's sometimes these places where you've seen the picture in the magazines and they look amazing. But when you get close, you see the nitty-gritty details of reality. And they're not always as pleasant as you thought, and they're not always expected. So we have to go, and this is the part where we go beyond the hype. We have to look at the reality of these things as well. There's always more to it than what the brochures say, or Twitter, or LinkedIn in our case. And there's this other thing that is part of the big hype, and that's event sourcing. And there's a lot of misconception around event sourcing. Now, you might think you're doing event sourcing in some places, right? You're using events to generate state in parts of your system. In reality, you're probably not, because there's something special about event sourcing that is not often very well understood. But while writing this, I did notice that actually almost every single developer uses event sourcing, except they don't use it in the place where they expect it. So let's go into event sourcing, what that is. So imagine we've got two services, and service A takes action. It makes decisions in our system. It gets requests to handle something, and it will make decisions based on those requests. As it makes those decisions, it will publish an event, and it can put that event onto an event stream, right? It could be anything that just stores these events. And then service B, whenever it's ready, it can consume those events from that same event stream. And that's great, but that's not event sourcing. That is event streaming. Right? Event streaming is when we have one source and another destination, and they are basically streaming events from one place to another. Event sourcing is a little bit more subtle than that. It means that service A does not have any state for itself. It doesn't store any state, but it bases every decision that it makes on the event stream that it also puts its events on. In other words, it makes the decision based on the events that it generated in the past. And when you do that, and when you use exclusively those events, caching aside, then that is event streaming. So, event sourcing. So in event streaming, there's two components involved. in event sourcing, there's always only one component involved. In reality, event sourcing is also a very good source for event streaming. Why not use the events for event streaming if you use them for event sourcing? And the whole idea behind event sourcing is the following. Imagine certain things happen inside of a system, right? And in our case, we've created an order. In most of the systems, in state storage systems, we just store the current state of that order. So in our case, that would be the order ID and some status. It's awaiting confirmation. And as we add an item, we update the state of our database, essentially. So we add those two items to it. If somebody removes an item, we update the state again, and we remove that one item from the event store. When we confirm the order, we change the status. And as we go on, every time something happens in our system, we update the state to reflect what happened. But if we look at the left and the right, the real value, the information that is of value to us is on the left. Yet that is the stuff we throw away typically, and we store the information that's on the right. And I wonder, why do we throw away all of that value? Well, there's a lot of answers to that question, and one of them, it's very complicated. Well, we'll talk about that in a second. And the idea of event sourcing is to capture the value and throw away the current state. We can derive the current state from the stuff on the left. So why use that in the first place? Let's not store that. And because we use the past events to decide which next event to generate, event sourcing basically gives us the truth, the whole truth, and nothing but the truth. Because whatever that store says, or whatever that stream of events says, that is what happens. And if something happened, it only happened because it was added to that stream. And if it didn't happen, it just means it's not there. So if it's not there, it didn't happen. And that is a guarantee that is very difficult to give in any system where you use events that does not use event sourcing. So why would you use it? Well, there's a couple of business reasons. One is it makes your decisions very reliable. It makes them very auditable and traceable. You know exactly what happened, because if it happened, there's a trace of it. If there's no trace of it, it didn't happen. It's that simple. So that makes it very useful for auditing, compliance. If you have transparent data transparency requirements, all very useful. We also know its value for data mining and analytics later on. However, not all use cases are as evident as these. In some cases, the reasons of real value are more technical in nature. And what we have found, and there's a lot of reasons, and some of them may actually be of value to you, and some of them may not. But the last one is the one I like the best personally. To deal with the complexity in your system. In very complex systems, it's so much easier to reason about what happened and think about if this happened in the past, then this should not happen. Right? So the way of thinking in event-driven systems is very powerful, and it aligns much better with how humans think in real life. If you ask a little child after a day of school, how was your day? Or besides saying, yeah, it was okay. If you actually get a story out of them, they typically tell you well, and this happened, and then that, and then that, and then that. That's because the event-driven nature of reacting with our environment is very natural to us. Yet somewhere in university, we've all unlearned this and learned how to map everything that happens in the world to a relational model. And now we are focused on that relational model. So let's try to get that back, get back the 6-year-olds in ourselves and go back to the what happened kind of storylines. And that's really nice. That means that you know how you got there, but how do you answer questions about where you are right now? As an example, if you need to know the balance of your bank account, and the only thing you know is exactly when you got salary and what you've been spending in the past, it will become a very long story with your calculator in hand to figure out what your current balance is. So that is probably not the best way to deal with that in software systems. And this is where a concept of CQRS comes in, is very useful. So now that we have this trail of exactly what happened, it gives us a very reliable way to, well, keep track of what happens next, to make decisions, and it is a reliable source of information, but it's not the most performant source of information to answer any question. And that's where where CQRS is a powerful concept. It gives us the ability to separate the command part of our system, which is where the decisions are generated, from the projection part of our system, where the answers are generated to the questions that our users or APIs or whatsoever external systems may have. And the events stream, the event source, if you will, the event store in practice, is on the left side, where these command models, they to make their decisions, they will read the events that are relevant from the past, make new decisions, post these decisions into the event store, which are then streamed to the projection part. And these projections optimize our data so that we can quickly answer any questions that we may have about the current state of things. For example, what is my bank account balance right now? And usually when I talk about these topics, one question very quickly pops up. What about eventual consistency? What about if I do something, and then when I read the state, I don't see the state changes? Well, my first counter question would always be, if you do something, why do you ask questions about the current state right away? The answer would then be, yeah, because some third party requires it. Well, there's always ways to work around it. However, what I've learned is that people think eventual consistency is scary. However, the more you fight eventual consistency, because eventual consistency is part of life. That is how we interact with other people. If you send a letter and place a phone call to the company that you just sent a letter, they haven't received it. We know that. It takes a while. Yet in software, we've been grown accustomed to the fact that if we do something, everything immediately happens. But we don't have time for that anymore. People don't want to wait until the entire system is fully consistent anymore. So the more we fight that eventual consistency, the more we try to avoid it, I found that we get the one thing that is worse: eventual inconsistency. And what I'd like you to do is, inside of the systems that you have right now, figure out how often inconsistencies happen. Do you have some consolidation process somewhere that you've got several systems that say different things about the same state, and you need to consolidate somehow and figure out what the reality is? What is your source of truth? In state-based systems, very often you don't have that single source of truth anymore. You just have multiple truths, and each one tells their own truth. And that gets scary because there's no reliable truth anymore. The solution is very simple, again, in slides, in presentations. In reality, it's a little bit harder, but we'll get to that. The solution is to be event-driven. And the thing is, we are. Right? However, what we focus on is so much on the technology, but being event-driven is so much more than just taking your fancy technology and that's it. Right? What it really, really takes to be event-driven is Mr. Miyagi. Whoops, sorry. So this is a picture from a movie, Karate Kid, just in case you're a little bit younger than me. When I was a small kid, this one appeared in cinemas and TV. And it is about a young boy wanting to learn karate. I mean, it's an 80s movie about a boy that falls in love with a girl and he needs to convince her, whatever. And so what do? Well, you go to your local Japanese guy, you ask him to teach you karate, right? In the 80s, that was perfectly normal. So he goes to, the boy goes to Mr. Miyagi and asks him, I want you to teach me karate. And he says, well, here's a sponge and there's my car, and go wax my car. And what's the point? Why should I wax the car? And it was about a few things. One is discipline. That's the discipline of keeping going, right? Just do this, right? Don't just do as you're told sometimes. Sometimes that's useful. But it was also about practicing these muscle movements so that you get muscle memory. So you know when something happens, how to move and how to react to when that happens. And actually, microservices aren't that far from waxing cars. Fortunately, we don't have to wax cars. Our practices are somewhat different, but it does start way before the actual technology. Right? It starts before the actual karate fight that you need to practice. And practicing in event-driven systems building starts with reasoning about that system in terms of events. And a few very interesting techniques have emerged in the past couple of years, I have to say. There's domain-driven design is a very interesting one. The blue book that you see here on the picture was written in 2003. However, I think it is more relevant today than it was in 2003. And you also see that the popularity of domain-driven design has increased quite a lot. In case you haven't ventured into that domain yet, it's definitely worth it. Don't get distracted too much by the abstract conversations that are going on about domain-driven design. It is actually a very practical and pragmatic technique that you can use. And another one that Alberto Brandolini came up with is event storming. And event storming is a really interesting technique because it allows you to design not just software systems, but more any system that involves humans, I would say. And you can probably even use it when humans are not involved. And what it forces you to do is, in a more of a brainstorming fashion, think about the things that happen inside of this system, whether that system is software or related or not, right? Just describe the things that happen. And that makes a design more emergent. As soon as we think in past tense, we tend to think about facts, right? The things that actually happen, not what we want to happen or what should have happened. No, what actually happens. And when you do that, you get sort of a really nice view of an entire business process or about how people work together. And you can find problems inside of that system very easily. Then you can continue into more details, and you can actually design parts of the system and how it should work, how it currently works, etc., etc. A little bit more practical is the concept of event modeling. Event modeling, just like event storming, starts with the events. Describe what happens first, and then look at why does that happen? Which user interface was involved with the reason of that happening? When that happens, what does that influence? What screens do we have that should change because this now happened? Etc., etc. And it can trigger processes that when this happens, that process needs to kick in so that new decisions are made and other things happen, etc., etc. You can design the entire system using these techniques. But there's a thing about events. So events are so powerful, and they're so everywhere, even in our daily lives. You have to be careful because they generate a very awkward form of coupling. What they basically do is they obfuscate and invert the dependencies somewhat. We saw earlier that instead of one service just calling another service, that service can now publish an event, and the other service watches the events happening. So now there's a service looking at the other one to see if it needs to do something. And there's no clear line to follow anymore in these dependencies. And that's not a bad thing. That's actually a very good thing. But if you do that everywhere, it might become a bit difficult to track what happens and why. So there's a certain level of obfuscation involved. And this is something you should try at home. Well, don't blame me if things go completely wrong, but you cannot always communicate in past tense. You cannot use every sentence and just emit facts in that sentence. That doesn't work. I'm pretty sure you'll get into a fight at home, probably at the second sentence already, right? It simply doesn't work. So if humans don't communicate that way, why do we think that that is the best way to communicate in software systems? Not saying software systems are human, but very often they are more human than we think they are. Now let's go back to that reactive principles and the reactive, basically the diagram that has been around since the Reactive Manifesto appeared a long time ago, probably almost a decade ago by now. And let's have a look at what it says there. It says message driven, right? Let me zoom in, because that is really important. It says message driven. If we wanted it to say event driven, it would have said event driven. So why doesn't it say event driven? And that's because in microservices messaging, there is not just events. Events are one way to communicate, but we also have what we like to call commands and queries. So basically, those are the three reasons why a component inside of an architecture will want to talk to any other components. Now, events are very useful to emit facts, things that have happened in the past. And if you emit a fact, you can use past tense, and it doesn't really matter what others think of it. It's a fact. It happened, you just emit it, and they will have to deal with it. However, in some cases, a component will want to communicate to another component to trigger a side effect, to change the state of the system. And that may actually be refused by the other component. It can say, hey, that is a state change that I'm not accepting at this moment. So there is a form of acknowledgement and a form of responsibility that lies inside of another component. And for that, we use the command. So a command is a message that we can send to a component to ask that component to make a change to the system state. If that component agrees with the command, it commits an event to notify any other component that the state of that system has changed. And when a component is interested in the current state of the system, it can use a query for that. It will send a message, give me the current state of this and that, and it will get a message back with the information that it was requesting. So the queries follow a more request-reply style pattern. But they're not always just simple requests to a single component and then a reply from that component. In some cases, you will want to do scatter-gather queries, as you would do in a conference, typically on stage, where you do a raise of hands. You just ask one question, and whichever person is in the audience that feels like answering it can answer. I'm not going to wait indefinitely for all the answers. I'm going to wait a couple of seconds, count the number of hands, which is essentially my reduction function. I'm changing the individual booleans of hands going up and down and take my conclusion. And another type of query that we've identified is what we call the subscription query. Is a question that essentially starts with, keep me up to date on. So I want to know the state of the system as it is right now, but if that state, basically if the answer to my question changes, I want you to send me an update right away, instead of having me to ask you every time, and now what's the current state, and now what's the current state. Right? So instead of polling, we can now have a flow of information throughout our system. And that makes systems very responsive in the reactive definition. So event and message is not the same thing. And it doesn't really matter how you implement these types of messages. Yes, a command can simply be an HTTP invocation of an endpoint, and so can a query. However, if you use explicit messages, what you can get very easily is what is called location transparency. Location transparency is a property of a system where the components that communicate with each other do not know where these components are. And it can even be better than that. They don't even need to know which component they're communicating with. If you send a command, do you need to know the destination of that command? Or can you rely on some stereotyping of that message and then have whatever routing platform you use to route that type of command to a destination that is capable of handling it? And when you do that, it allows you to seamlessly navigate from a monolithic deployment where all of these components are inside of the same monolith to a somewhat microservice deployment, to maybe full microservices as you see fit. And this is where the powerful part of this location transparency comes, is that we can decide how much of these anti-modularity forces we can actually deal with and how much we really need to have this increasing number of deployment units and make sure that they match the non-functional requirements that we have. All right, so how hard can it be, right? This is very simple. We just use 3 different types of messages. We can just use HTTP, we use events, etc., etc. Well, there's a certain level of technical complexity involved, unfortunately. Think about consistency, right? We've talked about eventual consistency, but there's still certain boundaries where we need to guarantee that we have full consistency. For example, if we want to withdraw money from a bank account and we have a rule that we can only do that if sufficient funds are available, we need to make sure not to overdraw that account. And we need that account balance to be fully consistent for each action that we do on it. Right? We have to think about delivery guarantees. How do we guarantee that when we publish an event, it does indeed reach the destination at some point in time? How do we make sure that that point in time is not too far in the future? Right? The timeliness is very important as well. What about error handling, especially in asynchronous systems or in pub/sub style systems? How do you deal with an exception in a component that handles the event and is not able to, well, there's no user waiting anymore, so you can't tell the user, hey, something went wrong, try again. And that for those technical problems, we have tools. And I say we in a collective terms, of course, at Exonic, we definitely build those tools, and that's what we do. But the problems aren't new. However, in the last 10 years, the amount of tooling that we have available to us in general is increased so much that we have to think about the right tools to use. And I'm not talking about just the Kubernetes and the discovery mechanisms that we have, but there's a lot more tools also for event sourcing, for message-driven systems in general. So I would really recommend you to have a look around. And if you want to see some of those tools in action, right after this session, my colleague Steven van Belen will give you a hands-on introduction to CQRS and event sourcing. So he's taking it even further beyond the hype, looking at code. He promised me he had no slides, so I'm very curious to see if he kept to his promise. That I've been told happens in room 2, right after this session at 4 o'clock. And there's also a workshop that my colleagues Ivan and Sarah will be giving that starts at the other side of the. Basically, they tackle the Mr. Miyagi stuff of the event-driven systems, which is building a model using event modeling to design a system, and how do you translate that into working code. All right, I did go a little bit faster than usual just to make sure that we have a little bit of time left for questions, because I had to recover from that false start earlier. So if you have any questions, There's a lot more information to be found. You can go to our website. My colleagues have made a little landing page where you can find links to interesting information as well. So you can use that QR code or the short link to go there. If you have any questions, don't hesitate to send me an email or reach out on Twitter. You can see all of the information down below. And that gives us a few minutes for questions. Let me see. Here we go. So, are commands and queries bound to a certain bounded context, or are they allowed to cross boundaries? And I see my colleague is in that chat as well to answer that question already. But I'm afraid I'm going to have to play the universal answer to all questions related to domain-driven design, which is it depends. Now, if you can do that yourself, if you can answer that question yourself, you're a certified domain-driven design consultant. So are they bound to a context? Well, yeah, it depends. So some are and some are not. Right? In some cases, you will want a query. I mean, for example, give me a certain invoice. That is not a query that is limited to just the finance department. Right? Sales may want to see an invoice as well, or the customer themselves, or whatever. So that is probably a type of query that you want to expose beyond your context and say, hey, other departments, if you will, or other contexts may also find that information very useful. It is a good question to ask if you are working in using domain-driven design and you are familiar with bounded context, is be very aware of whether you want any type of message. Is it defined for use within that particular context, or is it defined for use in a broader context? So somebody says, this is what is used actually from DHL. We are able to track our posts and packages in real time. Yes, in fact, you could compare the concept of event sourcing with package tracking. We do have a few customers in that space as well. Although strictly speaking, you don't need event sourcing to implement that. But the thing is, with event sourcing, you basically get the type of tracking that you have with packages, but now for every single decision, every single process of your system, right? And we see the value for packages because it tells us where they are by tracking where they've been, right? So we can see sometimes very interesting paths that these packages have taken, and you wonder why they went east first before heading your way west, or vice versa. So in which kind of application you should not use CQRS? And that is a very good question. And it's a question I can't answer. So if you had asked me 7 years ago, I would have given you a list of applications where it is not useful. However, I've seen systems that were in my list of never, ever use it there because it is overkill. And I've seen how powerful and useful that was. So the question you should always ask is essentially, is there enough complexity in our system? And I'm not talking about the software system in this case, but in the domain, right? Is there enough complexity that we can add the complexity of CQRS to our architecture? I mean, it's not the simplest form, the simplest architectural style that we have out there. So you need a certain level of complexity inside of your domain to make good use of that. So I would say for the very, very simple kinds of application, you would probably not want to use it. And in some cases, when you are working on a certain application, it could be that you are working in a CQRS style environment, but your service is just one that is answering queries. It is just projecting information for use by users outside. right? There's actually a lot of questions. What do you do with an ever-growing event store? That's an interesting one. Why not leave them? If events are valuable, why throw them away? There's in some cases there's requirements for keeping them 10 years. In some cases you can archive some of the events to use for analytics later on, and maybe yes, they're worthless and then you can throw them away. The most important thing is if you use event sourcing, be sure to use a storage mechanism that is suitable for event sourcing, a proper event store. Not everything that stores events is an event store. So you, in that case, if you use those systems, it doesn't matter. The performance does not degrade as you store more data. Yes, you just need to have the disks available. I think we have a lot of questions. Oh yeah, I'm going to have to take that one. I think that will be the last. I'll try to stick around for a little bit longer. See if that works. Otherwise, we'll have to take those offline. Reach out to me if I haven't answered your question. What about GDPR? Because that is a very interesting one. GDPR is actually, if you read the law, it is about tracking what you've done, right? So it is very clear about that transparency, and a lot of these articles will basically say, track what you've done. So they are a perfect match with event sourcing, except that one little article that says, well, forget information that when customers require so. There's a few simple solutions to that. There's, depending on your jurisdiction, you can use crypto shredding. We've also seen techniques where you store the sensitive information, so basically the personal information outside of the events, because the law just says you need to forget the personal information of the users. They do not say that you must forget that you've ever sold an article to someone. So even without the personal information, there's a lot of value inside of those events. So one thing you don't want to do is just delete everything you know because somebody asks you to forget their personal details. There's a lot of value remaining in those events when you just remove the information for them. So I just want to give you that there's a couple of solutions, and if you're interested in more details, definitely reach out to me. You can see my details on screen or at axonic.io/JCON2021. Thanks a lot. I hope you'll have a great time at the rest of the conference, and yeah, looking forward to continue the conversation.